Hey, Nicole Mashburn again, and we're going to continue our discussion about the skin. All right, let me make sure I get a pen. There we go. All right, so the first thing I want to talk about with skin, we've talked about the functions of the skin, we've talked about the layers of the skin. Now I want to give you some more details about the skin, and I want to start by talking about skin color. That's kind of an obvious thing that we can see when we look at someone else. We can tell what the color of their skin is. And so when we talk about skin color, there's actually three pigments that work together to give us the color that we see. And one of them is called melanin. And this is the pigment that's made by melanocytes, okay? And when you think about melanocytes, they make a pigment that can be anywhere from a yellowish color to a reddish brown to dark brown to black, okay? And that's responsible for the actual colors that we see between different ethnic groups, okay? It's the color of the melanin. And it's made by these melanocytes, and it migrates to the keratinocytes, where I think I told you earlier, it makes a little shield, a little umbrella for the nucleus. So it kind of protects it from UV radiation from the sun. And if you're an albino, that means you don't have any melanin, so your skin would be very, very white. There'll be no melanin there. Also means you have a high risk of having sun damage, UV radiation damage to your DNA. Freckles and moles are just local accumulations of melanin. Now, when we think about how dark someone's skin is, it's not that they have a lot of melanocytes, okay? It's the color of the pigment. So you have a big granule of pigment, and depending on how dark that is, that tells you the color of the skin. So the darker the skin that you have, the darker the melanin you have, and the lighter the skin you have, the lighter the melanin you have. So darker people don't just have more melanocytes. That's not true. Their actual melanin is a darker color. We also get skin color from the foods that we eat. Keratin is from food, orangey yellow foods like carrots, okay? So carotene, so carrots, and pumpkins, and squash, and things like that. And so if you eat a lot of orange vegetables, it'll actually accumulate, and it'll accumulate really obviously in your palms and soles of your feet. So if you've ever had a child and you may have learned that when you want to introduce foods to them, you introduce them foods one at a time to make sure they don't have a reaction to it. And so maybe this week you're doing carrots, and so you're feeding your child carrots, several things, baby jars of carrots several times a day, and all of a sudden you notice they have kind of an orangey look to their skin. That's the keratin. So no harm, doesn't cause anything, but you may see as you if you go on some kind of a health kick or eating lots of orange vegetables, your skin may actually have an orangey cast to it, especially in your hands and feet. And then lastly, hemoglobin. Hemoglobin is found in your red blood cells, and that's the pigment. It actually is in your blood, and it binds iron. Remember, this is the symbol for iron, Fe. And so that's one of your pigments. So that pink cast that you see on people's skin, that is from the hemoglobin. So as you flush, if you get hot or embarrassed and the skin the blood goes to your skin and you get that red color, you're seeing the hemoglobin of the red blood cells. Now, some other things that can cause different colors are changes in blood flow. So as you vasodilate or vasoconstrict or shunt blood to and away from the skin, that changes your skin color. So if you blush, you're vasodilated, you're sending blood to your skin and gives you that red color. If you're pale or cold, you're taking blood away from the skin, that gives you that pale color. If you're cyanotic, that means you're going to have a blue cast, so you kind of look blue. And this is people who have low oxygen. So their hemoglobin's not fully loaded with oxygen, and so it doesn't look real red, and you get kind of a blue look. When you think about hemoglobin and that iron, as it binds that oxygen, I kind of like to think of it as like a rusty blood. If you were to put something iron out into the elements and oxidizes and it rusts and turns that red color, so blood that's fully loaded with iron, the iron that's fully loaded with oxygen is going to be a real bright red color. With low oxygen, it's going to be a darker color, and that makes you look blue. Jaundice, this is going to give you a yellow cast, especially in the whites of your eyes. That's going to be one of the things you see first is a yellowish cast. and that's an indication of a liver problem. This can be seen in newborns right after birth. Their livers haven't turned on yet, and they'll have jaundice, which is a problem with their bilirubin. And we'll talk about that as we move through your anatomy and physiology. But it's also a sign of people, if they get older, of cirrhosis, alcohol problems, cancer. Anytime the liver starts to have problems functioning, you may see this yellow cast due to jaundice. And then obviously a good old-fashioned tan. So if you lay out and your skin responds to that UV radiation, and what you're trying to do is you're making more melanin. So you're trying to make more melanin to cover that DNA to protect it. So a tan will obviously change the color of your skin by increasing the number of how much melanin you're producing. All right, your skin also has some appendages, so some extra things. And so most of these are derivatives. They're of the epidermis. They're types of epithelial tissue as well. You have sweat glands and oil glands. Remember, these are both exocrine, so that means there's a duct so that the fluid can go to the outside. And we're going to talk about the different types of sweat glands and the oil glands. You also have hair and the hair follicle where the hair is produced, and the nails. We're not going to spend a whole lot of time on the nails. Obviously, you're welcome to look in the book and read about that. We're going to focus our discussion today on the first three. All right, so your sweat glands, there's two different types of sweat glands. Remember, these are exocrine. And when you think about sweat glands, you have eccrine and apocrine, okay? And some people say eccrine and apocrine, so just however you can think of it. I like to overpronounce things sometimes to help me with my spelling, and also to help me for you guys to understand what I'm saying. So eccrine and apocrine, or eccrine and apocrine, however you want to say it. But these are your two types of sweat glands. So your eccrine sweat glands, again I say eccrine so you'll know, you can distinguish what I'm saying, are going to be the ones that make the salty sweat. Okay, so they're the salty sweat. You have a lot on your palms, your soles, think about sweaty palms, your forehead. You think about how you sweat. And this sweat is mostly water with some salt, it has some vitamin C, some antibodies, some dermacidins, metabolic wastes. These things can actually kind of cleanse your skin. They're antibacterial. And remember, these eccrine glands, because they're exocrine, they have a duct, and their main role is thermoregulation. Okay, so when you're hot, your eccrine glands turn on, and they produce all that salty sweat, and that salty sweat comes to the surface, it evaporates off, and that cools you off. It's also, you may, if you're scared or nervous, you may get eccrine sweat glands producing salty sweat as well in your hands and feet if you're really nervous. Now, what does this look like? Again, you're going to have a skin lab, but the eccrine glands, these are epithelial cells, so you can see they're making a tube. Okay, so here are this is the lumen. Okay, and so with that lumen, it's going to kind of go toward the surface, so that becomes your duct. So these cells here, these cells, they secrete the salty sweat, and that flows into the duct, and then flows out to the pores on the surface of your skin. Okay, that's an eccrine sweat gland. So you can see here's your eccrine sweat gland, here's your duct, and you can see the pore on the surface of the skin. All right. Now your apocrine sweat glands, these are found in your axillary and anogenital region. So put your A's together, A for axillary. And so think pubic, okay? So these are things that turn on at puberty, okay? So as you get toward puberty, these things start to turn on. You don't really use your apocrine sweat glands when you're young and in childhood. They turn on about the time your hormones start to rage during puberty. And these sweat glands, instead of making a salty sweat, they make a fatty sweat. And so this is a sweat that has fat and proteins. And another word for that is called sebum. And it is usually found near a hair follicle. So whereas the eccrine goes straight to the surface, when you find an apocrine sweat gland, there's usually going to be a hair follicle associated with it. So think about pubic hair. Your hair under your arms and your genital area starts to grow at puberty. So at that same time, these glands start to turn on. And so there's some thought that maybe they have some kind of evolutionary role as far as like sexual scent glands or something like that. Maybe that's why they're there. But they turn on, especially if you've ever been a parent. So your kid, when they're little and they're sweaty, they come up to you, and they really don't smell bad. Sweaty children don't smell bad. But somewhere around 11, 12, they come to you, and you're like, oh my goodness, you stink. That's because these have turned on. All right, so let's think about why do they stink. So let's imagine you had a beaker of Eckrine Salty Sweat and you had a beaker of Apocrine Fatty Sweat. If you were just to let that beaker of Salty Sweat sit and that beaker of Fatty Sweat sit, which one do you think is going to start to smell and rot? Yeah, the apocrine. So what happens is that fat, that's just food for bacteria. So when you start to have those apocrine sweat glands, the bacteria are going to flourish, they're going to eat all that fat, and so what you're smelling is the byproduct of the bacteria. So again, so the stinky sweat is the apocrine sweat. Now, you have some apocrine sweat glands or specialized forms of these glands in other parts of your body. They're a specialized type in your ear called ceruminous glands, and they literally make your earwax. Okay, so earwax is kind of like a special type of apocrine sweat gland. And then your mammary glands in the female, they make milk. So milk's just basically fatty sweat. So you have ceruminous glands and mammary glands are specialized apocrine glands. They both make some kind of a fatty liquid. Now, that's not to be confused with your oil glands, okay, your sebaceous glands. So don't get your apocrine glands and your sebaceous glands confused. You have these all over your body. Anywhere that you have hair, you're going to find sebaceous oil glands, okay? So if you have hair, you've got them. They also become active at puberty. They are in you, they're working your whole life, but they're going to kind of ramp up and become more active. So think about acne, so pimples and blackheads and that kind of thing. Those are associated with your sebaceous glands. So we all know you go through puberty and you start to break out. Again, they make something it's called sebum. It's also it's that oily, fatty secretion, and it's a bactericidal solution. So it's supposed to soften your hair and also kill the bacteria on your skin. So it works to soften hair and skin as it's being released. So if you look at a hair follicle, there's going to be these glands associated with it, and so the oil will be released near the hair follicle or in the hair follicle. So here is a sebaceous gland. So here's my hair follicle, and here's the sebaceous gland. And if you look at a sebaceous gland, it looks like a bunch of fried eggs. Okay, so here's my hair shaft and my follicle, and you'll see there's actually a duct taking the oil that it makes into the hair follicle so that it can go out to the surface of the hair. Again, you'll see this again in your skin lab. All right, then last we have our hair. And so why do we have hair? Several different reasons. One of the things, it allows us to alert us to the presence of things on our skin, so like an insect. So if you think back to the different types of touch receptors, you have your Pacinian touch receptors on your skin, but you got to push really hard for those to fire. But your Meissner's, they're on your fingers, okay, and on your thick skin. So how can you tell if something's crawling across your skin? Well, your hair follicles, they have little nerve endings associated with them, and as a bug walks across the skin and causes the hair to bend, that causes the nerve receptor of the hair follicle to fire. So if something's crawling across your skin, you're not feeling it on your skin, you're feeling it move the hair. Make sense? Okay. It also is protection. It helps guard the scalp from physical trauma. It helps protect against heat loss and sunlight, especially in other mammals. Think about animals that are totally covered in fur. They use their hair as a big coat. Okay, it also protects them. We have hair everywhere except on our palms and our soles, our lips, nipples, and parts of the external genitalia. Hair is just a bunch of dead keratinized cells kind of glued together. And it's a little harder than the keratin that you find in your skin. It's more durable than the keratin in your hair, in your skin, because hair can last forever. You can grow your hair for years, and it's much more durable than your skin. The same reason that your skin has color, melanins are found in your hair, and they come in the same pigments, yellow to black, and so the color of the melanin tells you what color your hair you have. So the darker the melanin, the darker the hair. As you get older and your hair becomes gray, the melanin production goes down, and you actually get bubbles in the hair shaft. So gray hair is really just clear hair with no melanin. The hair follicle, I'm going to show you a picture of that, but you've got your nerve endings, and you've also got arrector pili. So let me go ahead and move to my next slide. So this is my hair follicle here, and if you were to look in your book, you'll see that the epidermis just kind of comes down and around, and you've got those very similar layers that make up the hair follicle that make up the epidermis. And so this is the hair papilla, and so the hair is kind of being made down here, and then it moves out. So this would be the root of the hair, and then this would be the actual hair as it goes up and out of the skin. And then again, it's going to be down in the adipose region. And we'll show you again in your lab video about this. So what I wanted to point out to you is this something called the arrector pili muscle. So this is my hair, and this is the top of the skin, and there's a little smooth muscle here, and so when it contracts, it will kind of shift that hair and cause your hair to stand up on end. So that's what gives you goosebumps. And so it has several functions. So in mammals that need to regulate their temperature, if they're cold, that arrector pili muscle will contract, and their hair will stand up, and that creates space underneath the hair so air can be trapped and you can hold heat. It also will contract when you're nervous and scared. So if you ever notice when you're scared, the hair stands up on the back of your neck, that's that arrector pili muscle. And that could be an evolutionary holdover from the other mammals. If you think about a dog when it's scared or mad, and its hair stands up on end, it makes it look bigger, makes it look more threatening. So when you're scared, maybe that's you're trying to look scarier and bigger by putting your hair on end and kind of puffing your hair up. So anyway, arrector pili muscles give you goosebumps. And that's all I have on this. We're going to continue our discussion with burns and how the skin repairs itself.